The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I hope you all are doing good, safe in your house. And I could call few children on these days, and some of you I tried, but still I couldn't speak to you because maybe I couldn't get connected or maybe some other reason for that. Let me see. Children, what I want to tell you is keep calling, not frequently, at least occasionally, so that we have the intimacy between us, so that the teacher understands you better and you also understand the teacher. Okay. Now the first chapter is completed. I will be sending you the bullet points of each chapter and also the solved questions from HSS Live, because as of chemistry is concerned, most of the questions you will get, 90-95% you will get from those questions. So what I would suggest is, when I am taking class, you make sure that you jot down the important points, like running notes. You listen, you can make a pause, write the notes, again listen, write the notes, because running notes will help you much better. And after you have written the running notes, you go to the HSS Live website and make sure that you see what is being conveyed there, the notes what you get and what type of questions are being asked from that particular topic, so that you can do the revision. Children, when we come to school, in a day you learn around 7 period subjects you will learn continuously, right? Maths teacher comes, she takes the class, she goes immediately, chemistry teacher comes, finishes, physics teacher comes, goes, botany, like that continuously. But now you have your own time. The whole day is all yours. Maybe you get the video around 12 o'clock, but still around 7 to 8 hours of valuable time is with you. So it is you who decide what to do with that time. You can use it wisely by learning it, or you can just waste the time. So what I would suggest is, if you are seeing one video, make sure that you are thorough with that particular topics taken on that day, because you can do the revision on the very same day. Okay, so I know my children will be doing it. Do not take any pressure. Enjoy the subject. Have a smile on your face. Love the subject and then learn. Automatically things will get into your mind. Okay, so now we are going to start with the second chapter, but before that let me just do a small recap of the first chapter. The first chapter, we know some basic concepts of chemistry. This we have already been learning, but still in the first chapter it is just for us to get ourselves refreshed with the topics. We started with matter. We know matter is anything that has space and occupies mass, right? And classification, this was based on a different classification on a macroscopic level, because microscopic level or other level we were studying about solid, liquid, gases, the main three states of matter. But here on the macroscopic level, it is classified into mixtures and pure substances. Mixtures are further classified into homogeneous and heterogeneous, and pure substances into elements and compounds. And we then came into scientific notation, how to add, subtract, multiply, divide the numbers when it is given, and also we learnt about significant figures. Significant figures are not, what do you mean by significant? Significant means which are valid, which are important, right, which has got some priority. So we were having some 5 to 6 rules for writing a significant figure. Then we came into the most important part of the chapter, laws of chemical combination. Here we were learning about law of conservation of mass, where energy can neither be created nor be destroyed. We also learned about law of definite proportion, which says that whatever may be the source, the given compound will have exactly the same elements by proportion of weight. Then we also learnt about multiple proportion, where we studied if two elements can form two or more compounds, where the mass of one element with the fixed mass of another element will always have a whole number ratio, that is simple ratio. Then we went into Gay-Lussac's law. In Gay-Lussac's law, we also told that when the elements, when they are chemically combined or they are produced, what happens? They do so in a simple ratio at a constant temperature and pressure conditions. And the last one was Avogadro law, where equal volumes of all gases at same temperature and pressure will have equal number of molecules. So V is proportional to N, which we studied in the 10th standard with Avogadro law. Then we came into Dalton's atomic theory. In Dalton's atomic theory, 4 important points were given to us. The first one was matter has got indivisible atoms, and then we know identical elements or identical atoms will have the identical elements with same property. Different elements of atoms will have different properties, including mass. And the third property was compounds are made with atoms of different element. And the last one was during the chemical reaction, the atoms, they reorganize themselves, but they are neither created or not destroyed. Then we came into mole concept. In mole concept, we were focusing on atomic mass, molecular mass, relative atomic mass, average atomic mass. Then we went into percentage composition, where we also learnt about empirical formula and molecular formula. In empirical formula, we learned that these are nothing but a simple ratio that is giving about the elements present in the compound. But what is molecular formula? That gives the exact number of atoms that are present in the compound. Then the important topic which we studied was limiting reagent. Like I will give you an example where we have hydrogen and oxygen combining to give water, and we require 50 grams of hydrogen and 50 gram of oxygen. But during the reaction, we know we have only 30 grams of oxygen. So with that 30 grams of oxygen, when it is used, the reaction stops. So such a substance or a reactant which is available in less quantity, once when it gets consumed, the reaction stops or it limits the reaction. Such a reagent we call it as limiting reagent. The next one, the last one we studied was reaction in solutions, where we learnt about 4 important headings: mass percentage, mole fraction, molarity and molality. In each we were studying about mass of solute by mass of solution into 100. In mole fraction, number of solutes of A or number of solutes of B divided by the total number of moles of the solution. In molarity, we were focusing on number of moles of solute by volume of solution in liters, and in molality it was number of moles of solute by mass of the solvent in kilograms. Only in molality we used solvent in the denominator. So these were the topics which were mostly covered in the first chapter. If you see in board exam point of view, we may get all these for maybe 1 mark question. But here when the laws come, they may give you an example of a law and they may ask you which law it is and ask you to write the statement of the law. Or they may give you in 2 marks, state Gay-Lussac's law with an example, state law of conservation of mass with an example. Then Dalton's atomic theory, of course for 2 marks it is important. Limiting reagent, the question which is already there in the textbook, I will be giving you 1 more during revision, and then these you can get in 1 mark. Okay children. So don't worry children, because first chapter is over, it's an easy chapter for us. Try to do the revision and make sure that I'll be giving you some questions, asking you to submit to me, and by the time I'll give a fixed date for you to submit it. Now we will get back into the second chapter, structure of atom. Atomic structure. This we have been hearing right from 8th, 9th standard. I think from 9th standard you have started learning about Bohr's atomic model, Rutherford, Thomson and all those, right? But why children, so many scientists, they simply keep on proposing theories again and again? What do you think could be the reason? Yes, the only reason is that any theory I propose, what happens? Unless and until it is being accepted or it holds good for all the elements or for all the compounds, the law or the theory does not become valid. So in that situation only a new theory comes up. Am I right? Say in our class, if one child is giving a suggestion, let us do like this, teacher. But if it is not being okay for all the children, what happens? We don't take that suggestion into account. Instead, we look for some other new suggestion. The same thing happened with the scientist. Now, John Dalton was the first scientist or the first person to start the atomic theory, because he was so particular that there were so many atoms which are present everywhere. They play a very important role. But he was not very sure that, because he told matter consists of indivisible atoms, that is, atoms cannot be divided into further particles. But there came a new change where atom has got subatomic particles. Atoms are made up of subatomic particles. So that's how John Dalton's atomic theory was just reframed by the new scientist. So what was the drawbacks of the scientist who has all been behind the structure of atom? There were few drawbacks, or I would say a few problems which were existing. Those were, they could not be able to account for the stability of atom. What do you mean by stability? Whether this atom is stable or not, whether it can undergo a reaction or whether this element can participate in a chemical reaction. No, they were not able to account the stability of the atom. They are not able to compare the behavior of the elements with other elements. Like one element behavior in terms of physical or chemical properties, it could not be compared with the other element. So that was another problem. The third one was formation of different kinds of molecules. They were not able to give a clear idea, a picture about how these molecules are formed. What is the reason behind the formation of these different types of molecules? And the last and the most important was the origin and nature of the characteristics of electromagnetic radiation which were emitted or absorbed by these elements were not able to be described. Some elements or some atoms, I would say, has a tendency to emit electromagnetic radiation or to absorb the electromagnetic radiation. But if we are not able to find out the nature, the type of radiation or what is the characteristic feature of that particular radiation, that was a drawback by these scientists. So then what happened? The existence of subatomic particles came into life. Dalton was a good scientist who could very well explain about conservation of mass, definite proportion, law of multiple proportion. But he failed to find out that glass or when an ebonite rod, when it is rubbed with silk, it produces electric discharge. It produces electricity, generates electricity. So those were the simple experiments which can be seen by day-to-day life, but was failed by the scientist to explain or to give a valid theory explanation. So discovery of electron came into existence. Why to discover an electron? Electron is also a subatomic particle. When we say subatomic, these are present inside the atoms. So we have protons, electrons, neutrons called as subatomic particles. First, we are going to see discovery of electron. Michael Faraday. Now, Michael Faraday was a person who was behind the successful discovery of electron. Now, you will be studying about Faraday's law of electricity or Faraday's law in your 12th standard with respect to electron. Now, what did he say? When I am going to take a solution of an electrolyte. See children, we have been studying in 10th standard about galvanic cell, Daniel cell. You remember we used to take two beakers or a single beaker, two electrodes are immersed inside an electrolyte, and when electricity is passed, what is happening? Oxidation, reduction happens simultaneously, and you can see there is a liberation of some of the amount of metal or element, or there can be accumulation of an element also or a metal also, where it gets accumulated at the electrode itself. So that was basically the cause behind the discovery of electron, because we studied in galvanic cell that electrons are the charge carriers. In electrolytic solution, ions are the charge carriers. But now, how an electron is present? How can I verify or how can I justify that an electron is present is Michael Faraday through his experiment. What did he studied in the initial stage was when electricity was passed through a solution of an electrolyte, chemical reaction starts occurring in the solution, where what happens at the electrodes? Liberation and accumulation or deposition occurs at the different electrodes. So now this he studied with the dispersion of the gases in a cathode ray tube. So this is what we are going to see now in the next slide about cathode ray experiment, where the presence of electron is being discovered. I told you we will be seeing about discovery of electron, that is which is taking place in a cathode ray discharge tube. See, this is my cathode ray discharge tube. This is given already in your textbook under discovery of electron. Now you can see this is a glass tube. This is a transparent glass tube where you have two thin metals. Two thin metals which are inserted, that will be acting as electrodes. What electrodes? Of course, one will be a cathode, the other one should be anode. So here in this cathode ray discharge tube, my negative electrode is cathode and positive electrode is anode. And the two ends of the electrodes are connected to the high voltage. Remember children, they are connected to a high voltage, both the ends of the electrodes. And you have a vacuum pump here to adjust the pressure inside the sealed glass tube, which has got the discharge of gases. So I will explain again. You have a glass tube, you have two thin metals which acts as electrodes, one being a negative electrode cathode, the other being a positive electrode anode. Both the ends of the electrode are connected to a high voltage battery. You have a vacuum pump, or I can say evacuation pump for discharging the pressure, that is to adjust the pressure of the gases. What you should remember in this is like charges repel and unlike charges attract. Why I am saying this, I will just come to you once we finish the experiment. So this was discovered in 1850 by Michael Faraday, and what did he say is that when electricity is passed, that is when a high voltage is applied, first he tried with 100 volt, he then tried it with 50 and then with 1000 volts, but still he could not find out anything that is happening in the glass tube. Then he decided to increase the voltage to a greater extent. That's how he increased with around 10,000 volts. Imagine children, something with 10,000 volts, what could happen, right? Definitely it would trigger the electrode, right? Then that is what he wants. He wanted to study the discovery of electron, whether an electron, a subatomic particle, is present in an element. So what he did is he applied a very high voltage, adjusted the pressure at very low, that is around 0 atmospheric, or I would say 1 atmospheric pressure. Then he found out that there was stream of particles. Immediately when a 10,000 voltage or a higher voltage is applied between the electrodes, electricity started passing. So when electricity started, what will happen? You could see stream of particles which are moving from cathode to anode. Why it is not moving from anode to cathode? From there he understood that something that is getting attracted to my positive electron should be negatively charged. You are able to follow, children? Like charges repel. So the electrons will not go to my negative electrode because they are already negatively charged. So definitely unlike charges attract. My anode being positively charged, the electrons being negatively charged, it gets attracted to the positive end of the electrode, which is anode. So I could see the stream of particles moving from cathode to anode, and those rays are called as cathode rays or cathode ray particles. Now anything that we do, we need justification. Right? You do something, and when the teacher asks why did you do that, you just give your justification, that is your reason or your proof. This is because of that. So evidence, a proof is required for whatever experiment we do. So once this was done, a proof or an evidence was also found out to find out that electrons are traveling from cathode to anode. So that is what we will be seeing with another diagram. So I told you, children, there were stream of particles which were moving from the negative to the positive electrode, and those were called as electrons. Now how to verify that these are electrons, or there are some rays which are passing through the sealed tube. Now to find out that, what he did was, in the same glass tube he made a hole in the anode, that is the positive electrode. He made a hole in that, and he coated the backside of the tube with a phosphorescent or fluorescent material like zinc sulfide. So when he coated, what happened? As soon as the high voltage was applied, there was stream of particles moving through the hole. After hitting the anode, they strike the anode and they just fall on the phosphorescent material, making a bright spot on the zinc sulfide, that is making a bright spot on the fluorescent material. And after confirming the bright spot, we came to know that there are definitely some rays which are moving from cathode to anode. So there were some results which were based on the experiment. What are those 5 results? The first and foremost important is that cathode rays travel from cathode to anode, that is negative electrode to positive electrode. And the second point was, these are invisible rays, you cannot see it. These are invisible rays, and if you want to see, definitely you can use a fluorescent material to find out the areas where the rays has hit the electrode. The next one is, in the absence of electric and magnetic field, they do not have any deflection, they just travel in a straight line. I repeat, children, when there is no electric field or magnetic field, these cathode rays do not get distracted or deflected, they just travel in the straight line. And during the presence of electric and magnetic field, they just behave like any other negatively charged particles like electrons. So during the presence of electric and magnetic field, they behave like electrons or negatively charged particles. And the last and the most important is, cathode rays do not depend on the material of the electrode and the nature of the gas used in the glass tube, which means they are independent. Whatever may be the gas or whatever may be the nature of the electrode, the cathode rays are independent. They do not worry about the nature of the gas and the electrode. So these are the things which comes under cathode ray experiment. This is very important and a definite board question. So next we will see about charge to mass ratio of electron.
Dalton's atomic theory was proposed in the early 1800s by John Dalton, an English scientist. Dalton proposed that every element, meaning all matter on Earth, is composed of tiny, indivisible particles called atoms. These atoms cannot be created, destroyed, broken into smaller parts, or in any way transformed into atoms of another element. All of the atoms of the same element will always be identical in size, shape, and mass. Different elements will have different types of atoms. The atoms of different elements can be physically mixed together, or they can chemically combine in simple whole number ratios to form compounds. When atoms are separated, joined, or rearranged, a chemical reaction will occur. Dalton's atomic theory was partly correct and partly incorrect. Dalton said that atoms were indivisible particles, but the modern theory of atom proved this to be incorrect, since atoms can be further subdivided into smaller units of electrons, protons, and neutrons. Dalton also suggested that atoms of the same element will be identical in size, shape, and mass. It was later discovered that atoms of the same element can actually differ in mass. For example, the element hydrogen can be found in 3 variant forms: protium, deuterium, and tritium, each of which has different masses. Elements having different mass numbers but the same atomic numbers are referred to as isotopes.
Now we are going to see about the charge to mass ratio of an electron, that is charge of an electron with respect to the mass, what is the value or how it was being determined. Now this was designed by J.J. Thomson in the year 1897, where he wanted to find a relationship between the electric current, that is the charge, and also with respect to its mass. So what he did is, he took a tube where he connected 2 electrodes, cathode and anode, and there was a powerful magnet also kept, applied a high voltage, and then he applied some fluorescent material to see the presence of the rays that are travelling. And what he came to know is, when only electric field is applied, through this you can see the ray of particle moving but hitting only at the point A, when only electric field is applied. But when magnetic field is applied, the same ray, after coming close to my powerful magnet, it gets deflected and reaches point C. But how to find out whether it travels in a straight line or not? Because we studied that in the absence of electric and magnetic field, the rays travel in a straight line. But now, by balancing both electric and magnetic field in a proper measure, this scientist came to know that the ray could also travel in a straight line and hit the point B. And after doing several experiments, he calculated the value of the electron, that is its charge with respect to its mass. And he came into few conclusions after doing the experiment. What were those? The magnitude of the negative charge of the particle, which means greater is the charge of the particle, greater is the interaction with the electric and magnetic field. If I have more energy, I can run faster. If I have less energy, maybe I may not reach till the end. Am I right, children? See, if you are very active, you will work more. If you are not feeling well, what happens? You don't try to do any work. Similarly, when the charge of the particle was greater, was very high, it could have a lot of interaction with the electric and magnetic field. So the deflection was also greater. And mass of the particle plays a very important role. See, if I am going to throw a heavy ball, it may not fly faster. But if I am going to throw a ball which is light in weight, it can go to a greater extent. Am I right, children? Light objects will always fly higher or move faster. So he says when the mass of the particle is less, the deflection is again greater. And the last conclusion he said was strength of the electric and magnetic field. Applying a powerful electric and magnetic field, the deflection was greater and greater, and that could show with the Thomson's experiment. So after doing the experiment, he got a value for the mass, charge and mass ratio, which was 1.758820, it comes again, into 10 power 11 C kg inverse. What is C? C means coulombs, that is charge of electron in coulombs, COULOMBS, in coulombs, and mass in kg. So this was the value he found out with charge to mass ratio of an electron. This is very well explained in your textbook. Once you finish this video, definitely read the textbook. Those points are very, very important. Now we will get into charge of electron and discovery of protons and neutrons. With that, we can stop for today.
Milliken's oil drop experiment. In 1909, experimental physicist Robert Milliken succeeded in determining the charge of an electron through an experiment popularly known as Milliken's oil drop experiment. His structure for determining this consisted of an enclosed metal chamber. Inside the top was an atomizer that sprayed a fine mist of oil droplets. Below the atomizer were two plates which could receive an electric charge. The upper, a positively charged one with a small hole in the center, and on the chamber bottom, a negatively charged one. In the chamber wall, just above the bottom plate, a microscope was mounted, allowing Milliken to externally observe the falling droplets. Opposite the microscope was a source from which X-rays could be emitted. Milliken began by spraying oil into the upper part of the chamber. Some of the droplets fell through the small hole in the upper plate. The droplets fell quickly, at first due to gravity, but the air resistance caused them to reach terminal velocity. By measuring their terminal velocity, Milliken was able to calculate the mass of each oil droplet. He then switched on the source of X-rays, ionizing the air and causing electrons to attach themselves to the oil droplets, which resulted in one or more charges on the droplet. When there are no voltage applied, the fall of the droplet was determined by the mass and the viscosity of air through which they fell. Milliken then applied voltage by connecting the two plates to a battery, creating an electric field between the two plates. Once voltage was applied, droplets with a negative charge fell more slowly, stopped, or even rose, depending on the number of charges on them. Milliken increased the voltage, targeting a single droplet. He observed that at a certain voltage, the droplet deaccelerated and remained suspended in the air. At that point, the electric force on the droplet is exactly equal to the gravitational force. Droplets with more charges on them required higher voltages to remain suspended in the air. When a droplet was suspended in mid-air, its weight, mg, was equal to the electric force, Ge, where m is the mass of a droplet, g is the acceleration due to gravity, E is the electric force, and Q is the charge on the droplet. The charge on the droplet can be calculated using the formula Q times E is equal to m times G, or Q is equal to m times G over E. Summary. Milliken, with his oil drop experiment, could calculate the charge on the electron. The charge on the droplet can be calculated using the formula QE is equal to
important values for us are very important. First one is charge of the electron, which is 1.6022 10 power minus 19 coulomb. Very important, can come in 1 mark question. The next one is mass of the electron, which is 9.1 into 10 power minus 31. These two values we might be using in the problems in the second chapter. So, very important, please note it down. Now, we will be studying about discovery of protons and neutrons. How it came into discovery of protons and neutrons was that scientists, when they did experiment, they came to know that apart from the negative particles, there were also some positive rays which were present. That is, a modified cathode ray tube, when it was designed, he could find out that there are some positive rays which are moving in the glass tube, and he called it as canal rays. There were some properties of canal rays. Canal rays means positive rays. Canal rays depends on the nature of gas and electrodes. We said cathode rays are independent, but here canal rays are dependent, means if the nature of the gas is different, the rays property will also differ. The charge to mass ratio of the particles depends on the gas. There, since it was not depending on the gas, the charge by mass ratio was constant. It was only 1.7, but here if the gas is different, this value will also be different. Next one, behavior of particle is opposite to cathode rays with respect to electric and magnetic field. That is, during an electric and magnetic field, we were seeing that it travelled in the with respect to A, with respect to C, and with respect to B. But here it is not what is happening. Maybe with presence of electric field, when cathode rays is going to A, canal rays will move to C. So, it was moving in the opposite direction as that of a cathode rays. The last point is, some positive particles carry multiple fundamental units of electric charge. Electric charge has got only one unit. But here, because of the dependence of the gases and electrode, this positively charged particles, they carry more fundamental units. That is, not only with coulombs or kg or meter per second, they take different units. But we are not worried about that, so you need not break your head for that. You just have to memorize the points, because they may ask you 2 properties of cathode rays and 2 properties of canal rays, maybe for 1 or 2 marks. So, definite question again. Do not think teacher always says this question is important, this question is important. It has come in the previous board exams. That is why I said this lesson is very important. Now, I told you discovery of proton. So, proton is a light positively charged particle not having that big mass. Right. So, that was also founded, which was named as a proton. Again, scientist Chadwick, he found out that there was one more heavy particle other than proton and electron, which was neutral in charge, was not carrying any charges. So, that he named it as neutron. So, further experiments was not done to show the presence of this neutron, but still it was then led to the discovery of atomic models. So, next class we will be learning about atomic models. So, I will be including videos in this, animated videos for you to understand much better about this topic what we have discussed it today. Okay children. So, see the video for better understanding, and if you have any doubt, do call the teacher. Okay. Stay home, stay safe. Thank you children. Take care. Bye.
Canal rays. Canal rays are beams of positively charged ions produced in a discharge tube. In 1886, the German physicist Eugen Goldstein discovered canal rays and experimentally proved the existence of protons in the atom. Goldstein used a discharge tube containing air to low pressure. The tube had a perforated cathode at one end. When voltage of about 10,000 volts was applied to the discharge tube, a beam of rays was generated at the anode and passed through the perforated cathode. Because these rays passed through the perforations, the canals of the cathode, Goldstein named them canal rays. Since the canal rays are generated at the anode, which is the positive electrode, they are known as anode rays or positive rays. When the canal rays struck the walls of the discharge tube, they produced a faint red glow behind the cathode. Let's see the mechanism of the formation of canal rays. When the high voltage passes in the gas, the atoms separate into negatively charged particles and positively charged particles. These positively charged particles pass through the gas towards the cathode. Properties of canal rays. Canal rays travel in straight lines. If an object is placed in their path, they cast a shadow. The rays produce mechanical effect. When a paddle wheel is placed in their path, the paddle begins to spin. Summary. Goldstein's gas discharge tube experiment revealed canal rays. Canal rays are positively charged ions. These rays travel in straight lines and cause mechanical effect